Today, we're going to talk about software that's called Apptainer. And if you're wondering what in the world is Apptainer, it is and was called Singularity, but in November last year, it got transferred, the guidance of it from a corporation which had a community edition to the Linux Foundation, so it would be a fully open source project again. So it got transferred, and just a few weeks ago, version 1 of Apptainer was released, including with some new features, but I'm not going to talk about those today, some new features that are not in the previous versions of Singularity. So if you've heard of Singularity for using containers on our clusters, you're at the right spot. This is how you're going to do it henceforth once the packages are, the modules are fully installed on all systems. So what is Apptainer? What is a piece of container technology? Well, the logo is here. It is the same as Singularity logo. It just has an A in it. But it started out at Lawrence Berkeley National Lab, and it was created to run Linux applications on high-performance computing clusters, both portably and reproducibly. So basically, the software setup that's inside each container can run as is and be maintained as is. There's only one caveat of that because it is a container, and I'll talk about that in a moment. But basically, once you put the software into your container, you can keep it in there, and the idea is indefinitely into the future, you'll be able to just use that container and run it like you had it installed. And right now, if you're doing something really current, it doesn't seem like a big deal. But a few years down the road, when everything's been upgraded, and let's say something you have only can use the older stuff, then that will become a bigger deal. I should mention that if you have software configurations from, let's say, 7 years ago or 10 years ago, some of them are quite challenging to get to run on our clusters. And if that's the only way you can run it, especially if there's proprietary software or whatever, sometimes the solution to making it work is putting an older version of Linux. There's certain limitations and caveats with that, but generally within the last 10 years, it's possible. You put the older version of Linux in there with the older software, and then all of a sudden you can get that to work, thankfully, in most cases. So as I mentioned, this was originally called Singularity. Now it's called Apptainer. I also like the rename, besides just renaming the project so it's clear that it's under new management and all that kind of thing. The other thing is Singularity is really hard to Google for. If you Google for Singularity, you'll get all kinds of stuff about black holes and mathematical things and all that, when in fact you're looking for container technology. So Apptainer is nice because the first hit is Apptainer, and it's not an actual word in the language, so that really does help. It is installed not just on our compute clusters, but it's installed all over the place on other high-performance computing clusters and academic settings. So it's important. So if you're using Docker because you like using Docker in your computer and all that, that's fine. And there's other container technologies, but Singularity was specifically written so it could be run on high-performance computing clusters, honoring security and other concerns. So it's open source, and it is a way for users to have full control of your software environment. Now, a container virtualizes the operating system, okay? And that's another way of saying, let me put it this way. There's low overhead, but it doesn't change the underlying operating system on your computer. It's not emulating hardware. It is, you are forced to be under the kernel of the operating system that booted the computer. So that means it has to be Linux. You can't run Windows inside of an Apptainer container. And as long as the underlying kernel that the operating system booted with is okay with what you want to run, and generally that's fine because glibc in Linux is nicely, appropriately backwards compatible over the years. So that's taken care of. Then the rest goes into the image. So the idea here is anything you put into that container image is there for you to use. And when you're running something inside of it, the ideal way and the best way to use it is to have everything outside of it blocked out unless you brought it in. So this gives you a nice, clean, reproducible environment. So one of the consequences of that is if you are enjoying the use of CVMFS and other things on the cluster, that is not available inside the container for you to use. You can make paths available for space and that, and I'll talk about that, but you won't be able to bring in the software stack, certainly not easily inside the container. That's not the point of a container. The point of a container is to set up some piece of software in it a certain way that you need done a certain way, and then you use it within that, and not to be tied to all kinds of, I'll call it relative to the container, external software configurations. So we only support using Singularity and Apptainer on our clusters. So if you are using Docker, you need to convert your Docker image to a Singularity image, and that's possible. Okay, so for installing on our clusters, it's already installed Apptainer. Version 1 will be installed soon, literally moments before I just started. There are, I think, Cedar and Narval now have a module for Apptainer. I have checked very quickly the one on Narval. It seems to work good. The other ones are being brought up as we speak. Basically, if you've never used either Singularity before, don't worry, you'll just be able to use Apptainer, not a problem. But if you have used Singularity before, nothing's broken. Okay, I'll talk about that in a moment, but nothing's broken. So whether you use Singularity or Apptainer, for the most part, is irrelevant because version 1 of Apptainer is specifically meant to be as seamless a transition as possible. Now, if you want Apptainer on your own computer, it has to be a Linux system. You can have a virtual machine that runs Linux, so you can install it that way, okay? Or you can use Vagrant for Windows or Mac OS. Under Mac OS, only Vagrant will work. Under Windows, my understanding is Windows Subsystem for Linux, which also runs a Linux, that will work under Windows. Some people have told me I've not tested it myself. If you go to apptainer.org and go into the documentation, go to the admin documentation, and there's a whole section on installing Apptainer. Okay, to use Apptainer, all you're going to need to do is go module load Apptainer, okay? Or if Apptainer is not installed, or you, for some reason, everything's still Singularity with you, for now, you can still go module load Singularity. Those will be there for a while. And the only difference between the two are in those 3 bullets from the point of view of migrating. So if you were using Singularity and you are going to run Apptainer, or let's just say you're using Apptainer on our cluster, but there's another cluster you're using and they don't have Apptainer installed yet and you're using Singularity, what's the difference? The difference is pretty simple. The Singularity command is called Apptainer. So instead of writing Singularity, it's a little bit shorter. Apptainer, still long, but a little shorter. And all environment variables that have capital Singularity in them that you use with Singularity, those are now capital Apptainer. So those are the next 2 bullets. So pretty straightforward. If you have scripts or anything like this, or you're just typing commands, whatever it is, it's pretty straightforward. You're just changing Singularity to Apptainer. And if it was Singularity in uppercase for environment variables and that, you just change it to Apptainer in uppercase. Now, importantly, if you are running MPI programs from inside your container, it's very important the stuff inside your container was compiled inside your container, because that's all it can see. Don't compile it outside your container, compile it inside, okay? Just a minor aside, doesn't matter MPI or anything. What is inside the container is meant to be inside the container, not from somewhere else. So if you have an MPI program, make sure outside the container, you load MPI version 3 or higher. And I strongly recommend using the latest version of MPI available, so MPI version 4, load that. Even if inside the container you're using a different version of MPI, load that outside the container, okay? And don't use anything before 3. Basically, it can be made to work with version 2. It's difficult, and version 1 is next to impossible. So you want to be using version 3 or higher. Otherwise, you'll get these weird errors and things won't work and stuff like this. And you are much safer with the newer versions of MPI. And that's because something running inside the container has to talk to something outside the container, and the thing outside the container has to talk to everything running all over the cluster. So it's important that you load the latest version. The other thing that you want to do is in your Slurm SBatch job script for with your program, you're going to use Apptainer to run it, or Singularity to run it. I have a sample line there, somewhat simplified, but if it's really simple, that's what it would be. But a lot of people like to put MPI run or MPI exec, ignoring documentation that says otherwise. Always use srun if you're using Singularity this way, or Apptainer. So if you're running some MPI program inside of your container, use srun. Srun passes all kinds of extra options to MPI and takes care of a bunch of things. Okay, so if you're using MPI run and MPI exec, it may or may not work, but you really, really, really do want to use srun. Okay, so how do you get to use this? Well, normally you use a program, you type in the command and it runs, great, boom. With containers, just like virtual machines, you need to get something first in order to run it. And with a container, with Apptainer, you need to get a container that has Linux installed in it, some distribution of Linux. And realistically with some software that you actually want to run, because our clusters are already Linux. So what do you need a version of Linux inside of a container for if that's already installed in the cluster? You know, and truly, if it's already installed in the cluster, it works. Don't mess around with Apptainer or Singularity unless you truly need it for a feature that Apptainer or Singularity lets you do that you can't do on the cluster. But submit a ticket, ask for help first, because it could well be you can do it on the cluster and we can help you with that. But the first thing you got to do is you got to get that installation of Linux in an image or a file. It basically is a file from your point of view, unless you're used to setting up low-level images. And then it's nicer to say it's a file system. But that's what you need. You need everything in it. And the only 2 things you don't need. So if you had a hard drive and there is a way of doing it. It's not a trivial command to run, but if you had a hard drive of Linux and you just put everything on your hard drive into an image, that would be fine. That's the idea. So everything you need to run the programs are in that image. Now, because the container does not do anything with its own installed kernel, if there's one there, it doesn't have to be there, or a bootloader, it doesn't use the bootloader. Those 2 things don't need to be inside the image, but pretty much everything else does. So the easiest way and the use case for easily 99% of our users is they're building images that people have already, from images people have already built from Docker Hub almost always. You can build images from a directory and other scenarios. I'm not going to talk about that here, but Docker Hub is the most common, and there's all kinds of stuff. For example, NVIDIA has their Rapids images available, and you can pull those images and use those inside of Singularity. Some vendors for some programs even have it so you can just download the Singularity image, but in many cases, most vendors are producing, and open source project too, they're producing Docker images. So if you already use Docker or familiar with it, you're in luck. How do you use Docker? Well, Docker, you can pull a Docker image and you can say CentOS :latest, and that will give you the latest CentOS image. With Singularity, you put Docker : / or Apptainer, either way, synonymously, Apptainer, Singularity, they're all the same. So you just put Docker : / and then whatever you use with Docker to get that image. Or if you're on a website and they say, get this Docker image, whatever they say to get the Docker image, like CentOS : latest, that's what you would put after the //. So you can get, what Docker does is they have a name colon and a version. So CentOS : 8 will give you version 8. And you can do that for Debian and Ubuntu and all kinds of stuff. And some of them, you go to the Rapids website with NVIDIA, you will see that there's an nvcr.io thing. And if you just put that whole thing after Docker : / you'll be able to get the image. Now, when you go Apptainer build, what you're doing is you're going to be downloading, if you're using a Docker URL, you're going to be downloading the image, and the Docker format's not the same as the Singularity format. So that's an important thing to realize. So the commands here to build your image, straightforward, Apptainer build. You put the name of a .sif file you want. You can give it any name you want, just end it with .sif, okay? And then you put the Docker URL you want to pull things from. Conceptually, that's simple, but understand now the Rapids URL here pulls an image that compressed, the SIF file is compressed. So when compressed, it's 5.3 gigabytes in size. That is a lot of IO on the file system. And so what can happen is it can fail. If you're building something and it fails, if it downloads everything, it should probably download everything. You'll see it download all, and then you'll get to, it'll run some stuff. You might wait an hour or more even, and then all of a sudden it fails. We'll say out of memory. For example, you cannot build Rapids on Graham for this reason, because the login node Graham's login nodes are the only nodes with internet access. And using Docker, you need internet access, and a bunch of our clusters don't permit internet access from a compute node. So you can't salloc interactive job session and run these commands and say, I need 16 gigs of RAM or whatever to do it. So unfortunately, that won't work. So what happens is you go to build Rapids, which is a very large image on Graham, and you have no choice but to use the login node. And then you find out, oh, it runs out of memory. Okay, that's to prevent abuse on the login node, so that memory cutoff. So you have no choice then. If you get that out of memory error, do not try it again on Graham. Go to another cluster like Narval, and Rapids will build on Narval. And try that, or submit a ticket, ask for help. Or if you have your own computer, my number one recommendation, if you have the luxury of having your own computer with Linux and Apptainer or Singularity installed, build the image on your own computer. Okay. Make sure you're using a local hard drive if you can. It's not always possible in our clusters, but make sure you use your local hard drive. The reason is 5.3 gigabytes is the final compressed image size. To create that 5.3 gigabyte image, it has to be uncompressed. So it's at least approximately twice as large as that. And then it's doing all that reading and writing, and Docker is a bunch of layers. So it has to flatten, Singularity flattens all the layers. So it's going to be doing many, many gigabytes of reading and writing. And if you are on a network file system, it will take a while. Okay, so Rapids might take on my computer approximately, my own personal computer, approximately, let's just say 15 minutes to run. Okay, it'll be different on every computer, but it'll take that. On Narval, to build the same image, it will take over an hour, easy. Okay, and that's because there is no local hard drive to use on the login node. Okay, and if there is internet access, when you do an interactive SLF job session, then you can do that, and by all means do that. And but Slurm Tempter is not emitted by Slurm, so you unless you know the hard-coded path, you'd have to ask, submit a ticket, ask for help for that. I don't know what it is myself. You can't use that. So if you don't have a local hard drive, you're still going to be waiting, and that means for some images they will be effectively impossible to build. The Singularity and Apptainer documentation very clearly in the admin documentation say not to use any network file system. If you do, it might just fail and you won't know why. So understand it, many images will indeed build on the clusters, including on Project and Home and Scratch, which are all network file systems. But understand that they might just fail and you might not know why. Okay, so that's why I say submit a ticket, ask for help. In some cases, it is just easier for someone to build it and then upload it to the cluster, build it on a local machine or whatever. These are things that we're looking at and may in fact resolve over time, but it's just a reality. Because once you have the image, you're golden. You can do what you need and move forward. The main thing is getting that image to start with. Also, if you are using an image and you're using it consistently, and let's say you're doing bioinformatics or whatever your area is, feel free to let us know the image you're using, especially if you're using it as is from a certain location. And maybe we put these images in our CVMFS repository, and then they're just sitting there, and then you don't have to build the image. That's something we are looking at. Okay, so very importantly, if you do have the ability to build with your local hard drive, and if you are doing something, some users do more elaborate stuff, and they want to take the image, they get the initial image, and then they want to install a bunch of things, or maybe they don't want to initially, but then down the road they want to use that image and upgrade it and do things like that. If you want to do that, most of the Linux distributions require the package manager in those Linux distributions require root access to install new software. And because of that, you pretty much have no choice in those instances. Use a local hard drive, and when you do so, use sudo. So you have, where it's on a machine, you have root, so you can run it with root, and that will preserve all the file system permissions necessary that when you use the package manager later, you'll have to download the image to a machine that you have root on, and then you do sudo, and you'll be able to install all the packages that you need, because you'll need root to do that. There are other ways of getting around it, but there's all kinds of ways those ways can fail. The surefire way that just works is to use a Linux machine where you have root access. You will not be given sudo access to any of our clusters. So if you submit a ticket asking for that, the answer will be no. You can set up your own virtual machine with Linux and do it that way, that's fine. But if you're in that boat, know that's the case. If you need help with that, submit a ticket asking for help, and we can guide you with that. Okay, so using Apptainer. Well, there's a number of ways to use Apptainer. Okay, so if you had the Rapids SIF file downloaded, for example, you can have any number of images. So rapids.sif here is presumably the Rapids image that I mentioned earlier. Anything that uses NVIDIA, you're going to put the --NV, okay? So that's what the --NV is. And then you run a command in it. That's the myscript.sh. Okay, fine. So you can run a single command and you just go apptainer space run. Okay, there's also an exec, but run's a better option to use. Use run. Okay, so that's what you do. That runs a single command. And that's how you'll use it in your SBatch job scripts, pretty much. Okay, you only can run a single command, and that's at the end of the line now. If you want to run many commands interactively, let's say you're using an interactive job session. You know, once you don't need internet access anymore, you're okay. So you can go into an SLUP, do your interactive job, and then you can use the Apptainer shell command. So if you put shell, that will let you run interactive jobs with the image. Okay, so that's kind of nice. You can set up things. So if you're using Conda, for example, or SPAC, you can set up the environment you need to make things work. And to run, some of you want to run daemons, servers, basically. You want to run servers or things with background processes within one job. You can do that. It is very fraught with perils and issues if you do it in run daemons inside of your SBatch job, because you got to put ampersands and this and that and worry about properly shutting them down or whatever. There's all kinds of issues that can arise. So to avoid those issues, you can use, that's the use case for Apptainer Singularity, you can use Apptainer Singularity to run those daemons. And the way you do it is you go Apptainer instance start, okay, and then you say what your SIF file is, and then you give it a name, whatever name you want. And then the idea is you can use Apptainer run after that, okay, and then you can say instance : and the name each time, and that means it'll reuse the same instance that's running, okay, and you can run commands, and they can just run and quit, or you can have commands that run in the background. That's what the no-hup is on the third bullet. The no-hup will cause the command after it to run in the background. And then you can keep running commands, and this is great. Now, if Slurm kills your job, everything gets killed properly. No defunct processes, no weird stuff. When your job shuts down, even if you didn't properly, if you go instant stop, that will also kill everything. If there's an elegant, nice way to shut down your daemon that you need to do that you're running, fine. Make sure you do that before you run instant stop. But this avoids a bunch of the headaches when you run daemons. Okay, now the Apptainer Compute Canada documentation page is not available yet. It will be soon, very soon. The documentation is going to differ significantly. It's going to focus on getting Docker images and running and using Singularity, and the piece of advice on it that's going to be there, actually the advice I mentioned here, that's going to be on that page. Now, when you're using Apptainer run or Apptainer shell or Apptainer instance or Apptainer exec, those four commands, run, shell, instance, and exec, okay, you always want to use the -C, -lowercase c, or -lowercase e. I strongly recommend using the first one. Use them in the order listed. You have to use the other ones. Don't not use them. The reason is simple. What's inside your container is not what is outside. You want everything inside your container to only see what's inside, not what's outside. That makes it a little bit harder to use and set up initially, but it gives you a much cleaner software environment. -C, basically, if you don't do anything special, -C hides everything. Okay, you can't see your home directory, you can't see anything except stuff inside the container. So quite draconian, people at first say, oh, I don't want this, this doesn't look like what you want. It actually is what you want. Okay, dash lowercase c is a little bit nicer, and then dash e, it looks pretty nice. You don't have to do a lot of things, but you can run into issues because everything that's in your shell environment for Compute Canada's clusters with the lesser settings, or if you don't put it at all, everything from the shell environment goes into the environment variables, go into the container. And the Compute Canada environment has paths that the container does not have access to unless you make access. So use -C. The other thing is when you run anything, increasingly, I find when you run anything, I used to omit it all the time, and increasingly it's failing more and more. So if you have a container, always use the -W option. And on our clusters, when you're on our clusters, use the -W option. If you're using Singularity interactively, you know, you're on the command line typing in commands, the dir after the directory you put after -W, just make sure it's some empty directory somewhere on a file system that you have write access to. Do that. The reason is, if you don't, it will use the /temp or temporary FS mounts. And well, the temporary directory on most clusters is usually temp FS. It will use that, and on our clusters, there will be issues. You'll see failures and other things. But if you do -W and put in a directory that you have write access to, preferably empty, you know, just make an empty directory somewhere, put that -W, magically that thing will work. So use it. In an SBatch script, you want to set the -W option to be slurm tempter. Do that so your job runs. Slurm tempter should be space local to the node, and regardless, it's very fast, and you want that. And what the -W does is it sets temp and bar temp and a few other temp things inside your image to use that directory that you specified. So you want to choose fast space. So that directory probably should be in Scratch if you don't know where to put it. But regardless, you want to set it. Otherwise, you'll see, hey, this doesn't work. Why doesn't it work? And just adding -W and an empty directory that you have write access to, all of a sudden, the same command works. If you're using an NVIDIA GPU, use --NV when you use Singularity. That exposes the NVIDIA devices to the things in the container. Quick mention, you need to install the NVIDIA drivers as well in the container if you're going to use NVIDIA. Just put them in, and CUDA and all that will work. Finally, you have to, if you're going to use -C especially, but you want to tell Apptainer and Singularity to your home directories and all this stuff. So ideally, you want to put -B home, -B project, -B scratch. And if you do that every time you run your container, you'll be able to access all this space. Okay, so you really do want these options for them to maximize all chances of success. Okay, in the chat, I see -C or whatever with MPI. It doesn't, this goes for all programs, not just MPI. I would recommend using -C with MPI as well. Okay, so I'm going to talk about some examples here, and I'm just going to talk about these fairly quickly, and then I'll show a little bit off with Singularity and open up the questions. Rapids. So Rapids is a nice thing from NVIDIA for doing some work. We have a Compute Canada documentation page. If you go there, docs.computecanada.ca, and you choose, you search for Rapids, you'll have stuff come up. It'll give you instructions. The stuff I have here is not yet updated on that page yet, but I want to present a way of dealing with it. Now, you first have to get yourself an image, that SIF file. one way or another. No matter what you're doing with Singularity, you got to get that image. So you can submit a ticket, ask for help, and we can help you with that. Or if you want to, it's a Docker thing. You're on a website or your research community says, hey, just use this Docker image. Okay, so if it's an image you can just use and it's supposed to work, great. You can try that out. So you can try building the image. Now, to maximize your chances of success, you really do want to be on a local hard drive, and that's hard to do on our clusters. The closest approximation I currently know of is using local scratch if local scratch is available, but local scratch isn't necessarily a local hard drive. It is fast disk space that you can use. So if the cluster you're using has local scratch, you can go about using it. Now, exactly where in local scratch to use is a little bit hard to say. So what I have here just for slides is, let's set an environment variable workdir and make it local scratch /temp $home. But you could say workdir is somewhere in scratch, somewhere in your home directory or whatever. Just make sure it's somewhere you have space and it's a reasonably fast file system, because Singularity will do a lot of reading and writing and you will wait a long time. Then you make that directory, okay? And very importantly, if you're going to build images on our clusters, very importantly, you want to set the Singularity or Apptainer tempdir and cachedir environment variables. Set them with export. So tempdir and cachedir need to be somewhere. I just put these inside of the workdir. Tempdir gives it a random name, but you can just hard code that to a directory if you want. And cachedir, make that another directory, and then make a point, the next line after that is to make those directories. Why am I doing that? Because the build command does not let you control the number of cores being used with make squash fs, that's internal to it. Maybe a bug report to Apptainer is an order there. And also the login nodes, typically where there's internet access, there aren't on compute nodes. The temporary directory is RAMFS. TempFS is RAM, and you're limited on how much RAM you can use. You need to point these directories to disk space, and typically you want fast disk space. That's why cachedir. Cachedir is normally in your home directory, but Rapids is 5.3 gigabytes compressed. So the layers are about that, but putting them all together, and then there's cache stuff and that, you want a spot where it's fast disk space and sufficient disk space. So put it there, because when after you build your image, you don't need it anymore. You can delete those directories. Then you do a module load Apptainer, okay? And I missed changing this Singularity. It should be, but it'll still work. Apptainer build. Okay, you can give the name of the SIF file you want. I put $home here to put the SIF file in my home directory. Okay, and then you put the URL you need. And if that works, party, yay. If it doesn't work, then go to a different cluster, okay, and try it there, or submit a ticket asking for help. The rm-rf workdir, you want to delete this directory when you're done. There's no need to leave wasted gigabytes worth of files sitting in local scratch or anywhere else in your scratch space or project space, whatever you're using. Do use fast disk space. This is the best recipe for success that I've come up with so far when using our clusters. If you're just using your own system, then just run Singularity or Apptainer build and build the image. And when you're done, you can upload the image to the cluster. That on our cluster, by the way, that takes over an hour to run on Narval. It will fail on Graham due to login RAM use limits. And you have no way of knowing in advance. And I even tried taking the cache directory, bring it to the compute node, see if I can run the command on the compute node with everything in the cache directory, and it fails. It still wants to talk to the internet. So the current status quo is that you're best to do what I mentioned there. And that typically would be run on the login node. Now, once you got your image, you're in business. Then you can do an SL lock to your login node so you can test your image, make sure it works, and set up anything you need. Okay, so the way you do that is you make your SL lock, you open your thing, you put your account and all that stuff that you need. If you need a GPU, then put whatever you need for GPUs, etc. Give yourself whatever, an hour of time to do that. And then once you're in, you can go module load Apptainer. Okay, you can do this thing here, which I'll talk about in a moment. And then there's Apptainer environment new home. Interesting. Okay, and then you can go Apptainer shell, and shell lets you get an interactive session. So I want to use home project in Scratch, so I have -B's here. I want NVIDIA, so I want --NV. Oh, and I need that temporary directory thing I talked about, that W thing. If you don't do that, things will just crash all of a sudden or fail or whatever. So you need this capital W, and that's why up here I make this directory. I don't care what's in it. It'll be empty, but it will be used for reading and writing temporary stuff. And then I put the name of my SIF file. So you'll say, okay, but I also made a new home directory. Yeah, I made an empty directory. Why would I do that? And then I set this variable to new home. PWD is your current directory. I made this in the current directory. So what is this? Well, anything you put Apptainer EMV, or if you're using Singularity EMV, all caps, underscore. So any environment variable that starts with that will be put inside the container, even if you use --C. So if you go Apptainer EMV underscore new home, then the new home environment variable, notice on this export line down here, I just put new home, that is set to whatever this variable is set to. Now, if you're going to mention paths on the file system on our cluster, you better put -B home, -B project, and -B scratch. You better mount your disk space so you can see them. Otherwise, you won't be able to see them inside the container. So when you do that, the first thing you do is you set home to be new home. You do not want to use your home directory as home. That's a big problem. You don't want to do that. You want to set a new home inside your container. So that's why we did this here. Okay, wherever we're at, boom, we have this environment variable, and then inside the container, you manually set home to be new home. Then you can go CD home or just CD enter, and you can type PWD, and you'll see you're in that location. You go to LS, you'll be able to see files there. Awesome. You want that. You do not want to modify your bash RC in your cluster home directory. That is a nightmare. It's all kinds of problems, everything. Now, check that the GPU's around. We'll run NVIDIA-SMI. If that's not installed in your container, that's a problem. Rapids nicely has all the CUDA stuff and everything in it. So you'll see information. If you don't, then stop. There's a problem. If you need the GPU, obviously. Now, very, very interesting. Why did we set home? Well, now we're going to, Conda is installed inside the Rapids image. So you can use Conda. So you can go source, boom, that's inside the Rapids image. Okay, so you do that, and Conda, where will it install itself? In your home directory. You just set home to new home. So don't delete that new home directory after you set things up, because you'll have a bunch of Conda stuff in there. Okay, and then Conda activate Rapids after you source it, and then you can go Jupyter Lab. This is how you use Rapids, Jupyter Lab, and hostname-f on our cluster will get the name of the host and substitute the IP there. And you need to do that in order to have an SSH tunnel. The Rapids Compute Canada documentation talks about that. Okay, so you do your stuff, and when you're done, you can exit, and then the temporary directory is not needed, but you do want your new home directory. So that's conceptually what you're doing. And once you get that, once you get something to work with Rapids, okay, what you need to do is take what you did. So what did we do to get in here? The first thing we did was we set new home, okay? Then we sourced, right? We activate our Conda, and then we ran a command. So effectively, and I missed new home here, the first thing you need to do, well, actually, we don't need to set new home here because I put it in the other thing, but we need to source Conda, And if that doesn't work, hey, we're done. So put the commands you would run in a shell. Put all the commands you would run in a shell here, okay? And if you want, you can export home here again if you want, no problem. But you put your commands you need to run in the shell and the Python thing and put them all in a file. So my rapids run script, okay? Plus X that file, chmod plus X it in order to run it, okay? You want to activate Conda here. Now you need to write your S batch script, okay? So I didn't set my new home thing here, so I need to update my slides and I'll make sure that's correct after, but you need to export new home. Actually, Apptainer EMV and the new home is missing from both of these scripts. So you need to put those in there. Otherwise, nothing's going to work. But you have the MyRapid script. You run your image with everything it needs, including the Apptainer EMV new home equals directory that you've set up, right? So that inside you can export home. Okay, so all the commands you did in your shell go into a shell script in order to get your environment working. Then in this, your job is just module load Apptainer. Obviously, put your job requirements, and then you put Apptainer and all the options you need there after doing Apptainer EMV home. So my apologies, I missed out on the slide, but you need this export line as well. And when you have all of that, you're in business, it should work. If this is running, if the script is running MPI stuff, you need to make sure you put right in front of that MPI command srun. If and you need srun in Apptainer, and you don't use MPI run or MPI exec, you've got to be careful. You'll have to do some testing. But srun should appear before in front of Apptainer. It sets a bunch of environment variables. Okay, so now that's how you set that up. And the difference between this one and the next one, I changed the tool I'm talking about from Rapids to something else, but really it doesn't matter about the tool. It's all how you set it up. The difference between them is this Rapids configuration uses a directory in your account, somewhere on home, project, or scratch. That's how everything gets installed. So when this, I went one too far here, this new home business, that's in your account space, somewhere in a directory in your account space. That's what that is, okay? So if you want to do that, these steps, just change Rapids to be whatever you're doing, and these steps are what you want. Now, if you are not wanting to create a directory with your own space, okay, what can you do? You can create an overlay image file. This is a file that's like a part of your hard drive. When you install your computer, there's partitions where you can put different operating systems and that on. This file is kind of like that, okay? So you'll make this file big enough to hold all your files. Quick aside, if you have jobs that create literally millions of files in the same directory and stuff like this, you don't want to do that in our clusters, file systems. That will slow things down a lot. We strongly recommend against that. Instead, you would be wise to use Singularity, and you can actually use an overlay file. The overlay file, you can make the millions of files, but to our clusters file systems, it looks like one big file. So the file will be, if you need 10 gigs of space to do your stuff, then you'll probably have, I don't know, maybe an 11 gig file. You'll make it a little larger, and you'll create this file. Now, how do you do that? You go Apptainer, overlay, create, -- size, and then you put the number of megabytes, and then the file name you want. Obviously, do it somewhere you have space, and boom, that'll make a big file. Great. You still need the temp dir for the -w option. Do that, okay? But the only difference is when you run Singularity, you're going to go -- overlay, and you're going to specify that file, wherever that file is, specify it, okay? So now inside the image, so notice this is Singularity shell or Apptainer shell. Inside the image, I didn't do any new home business or Apptainer EMV environment variables, anything. I didn't do any of that. It's just Apptainer shell or Singularity shell. Boom, you specify the overlay. And now here, inside the image, the angle brackets here, I'm inside the shell. I'm inside my container. And I go make directory / new home. So this will make you a directory in the root directory, okay? And by default, the overlay image you can write to root, and that overlay is an overlay. So if you don't put this dash overlay here, you won't see it, okay? But if you put it in there, you will see it. So when you make that directory, great. Now inside the image, you set your home to that new home, okay? You do that, then you can do your Conda install, Conda activate, whatever you want to do, because you got your home directory inside the image. Boom, set things up. But it's now writing inside this file. It's not writing files on the file system. It's writing inside this big file. This case is 2 gigs. 4096 would be a 4 gig file, etc. So it's writing inside that file. You can't write to an SIF file. So if you're getting read errors or write errors because it's read only, it's trying to write inside the SIF file. So you type something wrong if that happens. So for SPAC, if you're following the instructions for SPAC, you have to do a git clone. The image obviously has to have git inside of it. Okay, and you do that, that would install it. Okay, and if you want to see how much space is in your overlay, you can just run df-h. Obviously that has to be installed inside your image. Okay, and then you, just like Conda, you source it. So sourcing SPAC, you would do this, and then you can go SPAC install or whatever, set up anything you want. Okay, then you can exit out of all that and get rid of your empty, what will now be empty temp directory. Okay, so that's how SPAC works. So you set it all up. That's the idea. You set what you need up once, hopefully, and then after that, you're able to just run commands, and then submitting jobs to Slurm. Okay, here's a better my run script where I do export the home directory we want. So you want to set that. And then you do your Conda activate, or in this case, we're using SPAC. So you just do this. Okay. Remember the chmod plus X this. Okay. And then your SPAC script, and you put whatever you need to do, run that job. Okay. And module load Apptainer, and you can Apptainer run it, and boom, and it should run. Why? Because inside the script, you set new home and you made sure to, hey, I missed it right here, so this would fail. I didn't put -- overlay. So I got to fix my slides up. My apologies, but it's just as well. It can happen to anyone where you forget to put an option, you run it, and then it doesn't run. Well, in this case, you need -- overlay as well. So back here, when I ran things to do Singularity shell, I did -- overlay with my overlay. I need to put that in. So that part needs to be with the run command as well. Otherwise, it can't see that, and those will be available for use. Now, last mention with these overlay files, they're real file systems. So specifically ext3 file systems. So you might discover one day you need more space. How do you get it? Well, the first thing you're going to discover if you run the command to make it larger is it tells you to run this command e2fsck. That checks your file system. It's just saying check your file system first. So you run this command. Boom. Obviously, nothing else should be using your overlay when you do this. So you do this, you check it. Awesome. It'll fix any problems or whatever with the file system. Then you can run resize 2fs. Use it with -p because it'll give you a progress bar, and tell it the new size you want. And you can use the letters after this. So G for gigabyte, T for terabyte. Okay, and make your image larger. You can make it smaller too. Don't make it smaller than what's in your image. If you want to make your image to the smallest size possible, then just go -B-M. And this will make the image as small as possible, but it won't go any smaller than what is possible. So if there's only a few megs free, it'll only shrink it by a few megs, but it won't destroy any files. So that's how you do that. Should you need, so if you make that overlay file, yes, it's fixed in size and you can't exceed it. That's good and bad, but sometimes you do want to exceed it, or let's say you realize it's way too big. If it's way too big, run it with this -M option first, make it a small amount. And then of course you probably want some free space in it. You might not need it, but if you want some free space in it, you can make it larger after that. And when you do any of these commands, make sure no jobs are using the overlay image at all. A quick demonstration. So if you go with your login, mine is my last name, Crenny, at norval.computecanada.ca, and apparently Cedar also works with Apptainer, but all the clusters have Singularity installed. And you go module load Apptainer, okay. Then you can run Apptainer and you should see an output like this. Okay, if you do module load Singularity, you will as well. Nicely, if you have scripts, Apptainer has a symlink. So if you did module load Apptainer, everything will still work because Apptainer even has a symlink for Singularity. So if you just type Singularity, it'll do the same thing. It'll run Apptainer. But if you miss something in your script, you don't have to panic. Right now, there is, you can type Singularity as well. But if you can, use Apptainer, so module load Apptainer, and then you can do Apptainer. Now, next thing, if you want to use an overlay image, then you would just type the command I had there. So Apptainer overlay, and then you can say create, and you can say size, and let's just make a small one. I'll make 100 megabyte, way too small, but we can make it. And I'll call this overlay.img. There we go. Make sure you do it somewhere with a sufficient disk space, of course. So now this will make a file. So if I just look at overlay.img, there we go. There's a file, and it's nicely 100 megs. Actually, it looks like it does power of 2 stuff for us. Great. So there's my overlay image. Okay. Next problem, you need an image. I'm not going to do any Singularity or Apptainer build things here. They take too long, and we're at the end of our time anyways, but they take too long. So I will use an image I already have. So what I want to do is if I use -C, and let's use this interactively, -C, I'm going to use -C, and I'm going to use my image in the overlay and show a couple things. I'm not going to put -B at all. I'm not going to do any bind mounts, and you're going to see why you want the bind mounts. Okay, so I have my image. Oh, I need my overlay. I would put my overlay, and I want the overlay image file. And I have in here an image that I can use. That's already there, so we'll do this. Now, if I do this, okay, I get in. Great. Now, if you're running Singularity, you'll see Singularity. If you're running Apptainer, you'll see Apptainer. That tells you you're inside the container. Okay, very important. Now, the next thing, if I type ls, where are my files? Right? ls/home. Oh, it shows home Crenny. Okay, ls there. Where are my files? They're not there. -C causes them to not be there. Okay, so that's one thing I want to show. So -C causes them to not be there. So if you want to see your files, then do these bind mounts, and they will allow you to see all of your files and use Scratch on the clusters. So now if I hit enter with this, so whether you're using run or shell, do this. Okay, and now if I type ls, hey, I can see stuff. I'm in my home directory. Awesome. This is good. Okay, by the way, even if you're not in your home directory, let me go into public. In public, there are those 2 files. And if I run Apptainer again, and this time I gotta say one directory up for the overlay. Okay, oops, that's in this directory. Okay, so now if I'm not in my home directory and I go into the container, it will put me into my home directory. This is why the first thing I said, you want to set the home directory. So if you have an overlay, you can do that. So I can do make dir new home. You don't have to call it new home, but I can do that. There we go. Now, I can't do that on the normal file system. It'll give me an error. You can't make a directory in the root directory of the file system. That's impossible to do. That is doing that inside my overlay. So now if I export home equals /new home, there I go. So now if I go cd and just hit enter, pwd, I'm in this home directory. So now, once that's set up, now you can install Conda. Now you can install SPAC. Now you can do everything you need, as long as that overlay has sufficient space. Okay, I'm not going to do that here, just we're out of time, but you can run those commands to install those things because the home directory is set to something different. And when you do an SBatch job later, you want to make sure you set the home before you do anything else. Set home and then do a Conda activate or an activate on SPAC or whatever tools you're using. Set that up first in a script and then put the commands you want to run. Okay, and just to prove this here, if I go make dir new home, so, you know, exit to get out of all that, fine, but if I do permission denied. So it did those changes inside this file here. And this file, overlay image, and you'll see it doesn't change in size. That's the size of the file. Okay, if you want to see its size, and we'll leave it at that for this. Is this the right one? No, this one. Yeah, okay. Dot. There we go. Okay, if you run inside your image using an overlay, df-h, you'll notice a line with overlay in it. Okay, so I'm using 93, it's 93 megabytes in size. There's always a little bit of overhead every file system. So you should always go a little bit higher. I'm using 100K, that overhead plus the directory I made. Okay, so I have 88 megs available. So you can see I don't have the full amount available. It is a file system, so always inflate the amount you need by a little bit, so you're good. But that overlay is mounted at root, and so you can do stuff. Okay, so that's how you know if you have enough space or if you need more space. And if you need more space, you can leave the container completely. So you type exit and get out, you're back at the prompt, you can see at Narval, okay, there we go. And all you have to do is do resize 2fs, okay, with the -p, you can put your overlay file and then what you want to go to, let's say 200 megs, and you do that, and it will say, oh, run this command first. Okay, well, you can copy that, do that, it will check the file system, and now you can run that command and it'll resize it. This is really small, so it'll be quick, but if you're gigabytes in size, it'll take a little bit of time. I'll open it up to questions. Thank you.